Hello, my name is Amy Greiner. Today is January 12th, 2026. Today I will be explaining reaction 9, which is a Gilman reagent conjugate addition. A conjugate addition is also known as a 1,4 addition, meaning the nucleophile adds to the fourth atom of a conjugated system rather than directly to the carbonyl. I will be explaining what that means and how the reaction works throughout this presentation. My assigned reaction is number 9, which is a conjugate or 1,4 addition involving a Gilman reagent. This type of reaction occurs specifically with conjugated systems, where an alkene is directly connected to a carbonyl group. Because these two functional groups are connected, electrons can move across the system through resonance, which is what allows the nucleophile to attack a different position than expected. The nucleophile in this reaction is dimethylcuprate, abbreviated as CH3CuLi. The reactive part of the nucleophile is the methyl group attached to copper, which is the group that ultimately forms the new carbon-carbon bond. Copper makes this nucleophile less reactive than Grignard or organolithium reagents. Because of this reduced reactivity, Gilman reagents are considered soft nucleophiles and tend to favor conjugate addition. The electrophile in this reaction is the 2-carbon, also called the B-carbon, of the unsaturated ketone, which becomes electrophilic due to resonance within the conjugated system. In the first step of the mechanism, one methyl group from the Gilman reagent attacks the 2-carbon of the unsaturated ketone. A curved arrow is drawn from the carbon to copper bond to the B-carbon to show this bond formation. At the same time, the alkene electrons shift toward the carbon next to the carbonyl, and the carbonyl pi electrons are pushed onto the oxygen. These electron movements happen together and result in the formation of a stabilized copper enolate intermediate. Next, a neutralizing aqueous workup occurs. During this step, the enolate oxygen is protonated, which removes the negative charge and restores the carbonyl group. This produces the final saturated ketone. Electron movement starts at the nucleophilic methyl group of the Gilman reagent. The electrons are drawn toward the B-carbon or 2-carbon of the conjugated system. The electrons are then delocalized through the alkene and carbonyl, which helps stabilize the intermediate by spreading out the negative charge onto oxygen. During the aqueous workup, protonation stabilizes the molecule and completes this reaction. This reaction shows high regiochemical selectivity for 1,4 conjugate addition. Unlike stronger nucleophiles, Gilman reagents do not favor 1,2 addition at the carbonyl carbon. In addition, the nucleophile reacts on the least sterically hindered face of the bicyclic system. The rigid structure of the molecule controls which face is accessible, leading to facial and stereochemical selectivity in the final product. In conclusion, Gilman reagents act as soft nucleophiles in conjugate addition reactions. This reaction proceeds through a 1,4 addition mechanism involving the formation of a stabilized copper enolate intermediate. An aqueous workup restores the carbonyl group, and the reaction shows high regiochemical and stereochemical selectivity, ultimately producing a saturated ketone. These features make Gilman reagents especially useful for controlled carbon-to-carbon bond formation or inorganic synthesis. Thank you for watching.